In this video, I'm going to describe formation of ions from atoms. So from the atoms chapter, we saw that atoms in the element have the same number of protons and electrons because they must be electrically balanced, that is to say a total zero charge. However, when atoms react with each other, it's no longer the case that they necessarily have the same number of electrons as protons. If this number is different, you have what is called an ion. And so the first example we're going to talk about is ions which are consisted of a single atom that has lost or gained electrons. So for example, let's take sodium. In the periodic table, it's got 11 protons and 11 electrons. Okay, and the electron configuration is 1s2, 2s2, 2p6, 3s1. All right. Now, the driving force for sodium's chemistry is that this 3s electron is actually very loosely held to the atom compared to most other elements. Now, if sodium is by itself, yes, it will be there, and it will stay on sodium. However, in nature, we'll find that sodium will have 11 protons. We can't change this number. It's in the nucleus. And 10 electrons. And so, since it has 11 pluses and 10 minuses, it is a net +1 charge. And we generally don't write the 1 if it's a +1. We just put the plus sign. And so that 11th electron used to be in the outer shell, n equals 3, is now gone. And so the electron configuration is 1s2, 2s2, 2p6. This is the same electron configuration that neon has, and so we use the word isoelectronic to indicate something has the same electron configuration. Okay, that means the same number of electrons and also the same orbitals being occupied with the same number of electrons. Okay, so that's sodium. Magnesium is after sodium, and it has 12 protons and 12 electrons. In electron configuration, it has one more electron here, so it has 1s2, 2s2, 2p6, 3s2. Okay. Well, magnesium loses not just one electron, but also loses the second electron as well. And so magnesium 2+ will be the ion that has 10 electrons instead of 12. And it'll have the electron configuration 1s2, 2s2, 2p6, full stop. And so neon atom, neutral, sodium cation, +1 charge, and magnesium dication, +2 charge, all have the same electron configuration. So this is really the driving force for metals. Metals like to lose electrons. How many they lose is dependent on where they are in the periodic table. If they're in column 1 of the periodic table, they will lose 1 electron. If they're in column 2 of the periodic table, called the alkaline earths, then they will lose 2 electrons when we find them in nature. Aluminum loses 3. The ones in the middle, they have too many electrons, particularly those in the D subshell, up to 10 of them, that they don't lose all of the electrons to get back to the same electron configuration as the noble gas. So that's where you have different numbers of charges on different types of ions that we'll discuss later. Okay, well, electrons can't just leave and be by themselves. They have to go somewhere. So we have to talk about the other elements, the nonmetals. Okay, so metals lose electrons, nonmetals gain electrons. So for example, chlorine is going to have 17 protons and 17 electrons. Chloride gains an electron. So chlorine atom gains 1 electron, becomes the chloride ion. These are called cations. These are called anions. And so 17 protons. Again, we cannot change the number of protons without changing the element. So we can't do that. 18 electrons. All right, and so this has one more electron in the electron configuration than this one does. So let's just write down 1s2, 2s2, 2p6, 3s2, and then 3p. Okay, so for chlorine atom, this would be 3p5. For chloride, we have one more electron, and it'll be 3p6. And this has the same electron configuration as argon, also a noble gas. So the driving force for the nonmetals is to gain electrons so that they have the same number of electrons as the noble gas. That's next in the periodic table, right to them. And those charges will be determined by how many electrons it takes. So for example, in column 17, the halogens, they only need one more electron to get to the noble gas, so you'll find them as -1 charges. So fluoride, -1, chloride, -1, bromide, -1. Oxygen, on the other hand, has 2 electrons short of the noble gas neon, so oxide is found as O with 2 minus. And so oxide has this. So it has the same electron configuration as fluoride. So that's it for how ions form. Later on we'll talk about compounds made out of cations and anions.